Right then, good morning, everybody. Thanks for joining on this, what appears to be a sunny day, at least in London. Hope you're all well. We're going to get started with the content in just a second. And that second is going to be occupied by me pressing buttons in Zoom so that I can share my screen adequately, which I hope is that one and that button right there. Great. So you should be able to see my screen now. If you can't, do shout in the chat. This is a standard Zoom webinar. So in terms of housekeeping, we have a Q&A function in Zoom. So down the bottom of your screen, you'll see a button marked Q&A. If you have questions throughout the session or towards the end, you can hit that button and type them into a box and they will pop up on my screen just down here. And I will attempt to answer them as we go, or I might defer them until we're at the end. But yeah, do throw questions at me as we go. I am recording this webinar, so I'll be putting it up on our YouTube channel once we're done. The slide content will also be available to you. I will share a link to a page on the Scale Factory website once we're all wrapped up, where you can get at all of that stuff for your future delight, edification, and sharing with your friends and colleagues who might also benefit from some of this knowledge. Today, we're talking about secure SaaS networking with AWS PrivateLink, which hopefully you all know because that's why you signed up. And I guess the first question to answer is, well, who's this guy? My name's John. I run the Scale Factory. I founded it in 2009. I'm currently acting as CEO and CTO. We're still a sort of smallish startup size business, so obviously my job is pretty varied. Personally, I've been working in hosting and infrastructure for about 2 decades. It's been a large part of my professional career. In fact, the majority of it. And in case you care about things like certifications, I also have a couple of AWS certifications that hopefully demonstrate to you that I know what I'm talking about. And my interest in particular are infrastructure, AWS as a whole, and DevOps, although we don't really don't talk about DevOps quite as much as we used to. I think that's now just what we're doing, so it's sort of table stakes for the way we run infrastructure. So I don't make a big thing of it, but we're still very much a DevOps aligned practice. We're a member of the Amazon Web Services Consulting Partner Network. So we are certified to a particular level within the team. And we also have a number of competency and program memberships. So earlier this year, we received a competency designation for our work in SaaS because of the work that we've done, the sort of track record we have working with software as a service businesses, probably like yours. And we are also part of the well-architected framework. We're going to talk a bit more about well-architected later on. We can also run immersion days, which are a type of training and sort of content introduction session. So if you're interested in that, do let me know. As well as our AWS credentials, we are a Kubernetes certified service provider, which means that we can solve the Kubernetes problems that you undoubtedly have. And we're listed on the government G-Cloud supplier list. So if you're a public sector buyer, you can buy your services from us through the G-Cloud framework. We like to put people first at the Scale Factory. So here they are. These are the people that do all the hard work. My job is mostly webinars, spreadsheets, and emails these days. But these are the people who do the much more difficult task of actually building these things for clients. In terms of people we've worked with, there are maybe some names you recognise there. Looking at the list of participants today, some of you belong to these businesses, which is great. We've worked with larger organisations like Expedia and ITV. You might recognise there. Moo, you probably recognise, but also a range of businesses of all sorts of other sizes that you've maybe less familiar with. Startups, scale-ups, enterprises. We're quite happy with all of the above. We've worked within compliance environments such as pharma and healthcare, fintech, as well as e-commerce, media delivery. So we've worked across a range of clients. Many of these are software as a service vendors in some regard, and so we've worked a lot with those, which is why I think we're well qualified to talk about SaaS considerations today. Onto the agenda, we're going to talk a little bit about the security requirements that you may have as a software as a service company. I'm going to cover some of the common solutions, the things that you might be doing today if you're already an AWS customer who's building a SaaS. And then we'll go on to talk about AWS VPC networking, which is sort of the foundational underpinning of PrivateLink. We'll talk about the PrivateLink solutions to those problems. Then I'm going to hand over to Dara, who's from AWS and is also on this call. Dara and Nicholas, part of the AWS organization. Dara's going to talk a little bit about the APN Technology Partner program, and specifically how, if you use PrivateLink in your designs, they can support your business through a service readiness program. And then we'll wrap up, and there'll be plenty of time for questions. So I think we're probably going to go for at least an hour. We maybe go a little over. If you have to drift off earlier than that, then do so. You can catch up on the content on the video later on if you need. So let's talk about SaaS security. In general, I think these are the sorts of things that you're probably caring about if you're a SaaS business. So your tenants are interested in being separate from one another. Like they don't want to be in a position where their data is being shared with the other people that you're selling service to. That's a big no-no. They may be worried about storing commercially sensitive information on your platform, which I know a lot of the if you're selling business to business, and a lot of what we're talking about here really is a business to business SaaS situation. If you're selling to enterprises, then they probably want to be reasonably sure that you're not leaking their commercially sensitive secrets, either in your organization with other clients or more publicly than that. You probably have some compliance obligations. So if you're in the fintech sector or the pharma tech sector, maybe if you're processing card payments and so forth, you will have a set of requirements to follow that have been imposed by a government body of some sort. The compliance obligations tend to be the things that you have to do that are kind of not optional for the type of work you're doing. And so a lot of things around compliance are also security related. You probably also in the SaaS world, you maybe have some performance SLAs. So you might be giving a particular service level agreements to your clients about how quickly you can respond to requests, how much latency you're introducing, particularly if you're in the critical path for a transaction flow for your customers' platforms. And you probably have some availability SLAs as well. So your ability to stay up is something that you may well be measured on, and it may well be important for your customers. So these are all things that you probably want to be thinking about. If you're not thinking about some of those things, then it might be time to start. But these are sort of the areas that you're going to be looking at. The NCSC is a government organization that provides guidance on cybersecurity to people who are building platforms for the government. The NCSC guidance for SaaS security contains a handful of things, but specifically these two. They're particularly interested in data in transit protection between clients and service. So that's essentially encryption on the wire between your consumers and the service that you're building. And they also require you to be implementing industry good practice external certificate configuration. So proper TLS with appropriate cipher suites and adequate security on that score. So bearing all that in mind, this is the sort of thing that you've probably built. If you're a SaaS vendor, it's very likely that your platform looks like this. Over on the left, you've got the client, basically your users. That might be a person with a browser, as it is in this particular diagram example, but it might equally be a system on somebody else's network. They are going to be making a request with some TLS encryption, I hope, over the public internet, where obviously you're subject to internet weather, so the fluctuations in performance and availability that just happen as a result of the broader internet being a loosely connected set of tin cans with wire with string between them, where you can't really predict or own the performance or availability of any one part of it. That traffic is going to hit an application load balancer probably, or maybe an ELB or an NLB, but there'll be some load balancing in there probably. That load balancer is going to terminate your TLS session, and then that load balancer is going to distribute traffic across maybe a couple of availability zones, hopefully more than one, maybe 3 or 4 or 5, depending on where you are and what your availability requirements are. But this is the sort of simple case. Most people who think about building services on the internet are thinking about building things that look like this. And I guess to be clear, if you're building a B2C SaaS, you're selling to customers, this is perfectly reasonable, right? Your customers are going to be on the general internet. I think you probably don't need to worry too much about the private link story in the B2C world. But where we're talking B2B, we can probably do better. So the positive side of doing this sort of public HTTPS endpoint presentation of your service is that it's pretty easy to set up, right? It's well known. Anybody who's done infrastructure in your organization will probably know how to do this. The traffic is encrypted in transit, which is, of course, great. And all clients are essentially equal. So there's no network filtering. You're not putting IP lists in front of the load balancer here, probably. It's a publicly available service for all of your clients. The downside of this, of course, is that you are exposing this on the public internet, which may not be desirable for every type of service you're building. And the network access controls are a bit fiddly if you're trying to do this in a multi-tenant way. You might feel like you want to limit access to certain network ranges. You maybe are not going to be able to do that effectively. And also, I haven't added this to the bullets, but you're also then at the whims of of internet weather, which is that there's a lot of other people's infrastructure in between your client and your service that you don't have any real control over. You maybe have visibility of it, but there's nothing you can do about it if it starts to fail in the event that, say, there's a links failure, something goes horribly wrong in Telehouse in London, and all of the UK internet is boned to some extent. You can't really do anything about that, and you're going to suffer as a result. So you might look at, in a BCB model, this other approach, which is VPC peering. So if your customers are AWS users, and PrivateLink here really assumes that your customers are AWS users. This isn't a solution that's applicable outside of that environment. Your client users they have their own VPC. Maybe their software is the software that they're using to talk to your service exists in their network. And you can join together two VPCs, so your VPCs and the customers, using this peering relationship, which is a kind of bi-directional agreement where you both click on some stuff in the console or use some Terraform or CloudFormation to set up this relationship. And essentially this makes it possible to route your networks to each other over this peering link. You can make this a bit more complicated or involved with Transit Gateway, but essentially the story is that you have two networks that can see each other from your client's network and your own network. And again, you've got a load balancer. That load balancer probably lives in your private subnet, so there's no need for your VPC now to have any external internet access, because all of your clients are accessing over these peering links, and as a result, your stuff can stay a little bit more private. So in terms of the positives of this approach, like, it's a private network relationship. Your traffic is going entirely over AWS networking infrastructure. So we've ruled out this kind of internet weather problem. All these peering relationships can be cross-region as well, as of I think last year. So your traffic, if you're passing traffic to a client VPC over a VPC peering link into a different region, all that traffic is tunneled through Amazon's network, and so you're not again at the whims of internet weather in that case. The downside here is that peering routes are bidirectional. So a VPC peering relationship implies that not only can your customer route traffic to your to your load balancer, but it can route traffic into the rest of your network. These are simple, straightforward network routes. And bidirectional, it also means that you can send traffic into the customer's network. So if you haven't set up a good set of firewall rules or security groups or NACLs, then essentially you've maybe made life a little less secure for yourself, because you've potentially exposed your secrets and your internal infrastructure to your clients, and possibly they've done the same in reverse. So it's not ideal there. There's also a problem if you have a VPC network range that overlaps with the internal range that your client has chosen, then that VPC peering relationship won't work. And so if everybody's chosen 192.168/16, then you're not going to be able to peer those networks, because the network ranges overlap, and that's going to be a problem. You also need to do some stuff with routing tables, which isn't ideal from a sort of management perspective. So that's what the VPC peering looks like. It's a little more grown up than the public facing TLS endpoint, but it's not ideal because of these other reasons. So when I presented this webinar and started publicizing it, I asked this question, which was, what if you could expose your service as though it was part of your customer's own network without any of that traffic crossing the public internet? And so I'm going to get into the details of how we might do that. First of all, though, I'm going to talk about VPC endpoints and the VPC networking. It's my view that the Amazon naming and messaging and communication around PrivateLink and VPC endpoints isn't entirely clear. It's not obvious really what is PrivateLink versus what is a VPC endpoint. So that's some of the learning I've had to do to kind of put this content together. I'm hoping to demystify the sort of building blocks as a starting point and then move on from there. So this is your standard VPC network. If you're running, say, I've used EKS here, it could be any application service. Essentially what this diagram shows is how you, as a service within an AWS network, make requests out of that network for other things. So let's say that EKS container is going to go and talk to an external API, something off network, whatever that is, maybe Eventbrite or something like that. These are APIs that I work with a bit at the moment. Your service containers run here in a private network. That private network can only make requests outside of the platform by traversing a NAT gateway that is running in the public network that you've had to create and set up. Like, this might be a managed NAT gateway from AWS, or if you want to spend a quarter of the money on it, you might have built a NAT instance in your own network. Traffic leaving the NAT gateway then leaves your VPC via an internet gateway. So at this point, your traffic is heading out to the outside world and costing you some money, right? The bandwidth transfer out of an internet gateway is subject to AWS cost based on the size and the direction of that transfer. In the case of an access to an AWS service, let's say you are communicating with S3 from your container there. In the default setup, then that traffic is also going to traverse the NAT gateway, go out via the internet gateway and hit the S3 bucket. That's you're essentially communicating out of your VPC to public services, which are on the internet, but also happen to be AWS services. So any transfer through S3 is also going to be subject to cost, because you're essentially your traffic is leaving your VPC. And obviously the response is coming back from outside the VPC. What PrivateLink allows us to do is create something called a gateway endpoint. So a gateway endpoint is a thing that you add to your VPC, which provides the ability to pass traffic to an AWS service without it having to traverse your NAT gateway and your internet gateway. A gateway endpoint is a sort of is a special case of another type of endpoint, which we'll get onto in a second. But essentially, if you set up a gateway endpoint for S3 or you set up a gateway endpoint for DynamoDB, then any requests that you make of the S3 bucket or of your DynamoDB tables will traverse the gateway endpoint, are secured by PrivateLink, and then hit the AWS service without that traffic transiting your internet gateway, and thus without it generating transfer cost at the internet gateway level. These are special cases because the S3 service and the DynamoDB service, they are targeted by routing. So the gateway, basically what you're doing is identifying the routes to the S3 network and the DynamoDB network and passing those pieces of traffic through a gateway endpoint instead of via your internet gateway. This is all much more clear when you start looking at it in the setup and once you start configuring it. So don't worry if you don't understand this bit. The S3 and DynamoDB stuff is a bit of a special case. Doesn't apply to how we're going to be using PrivateLink to secure your service. Moving on from there, let's say instead of S3 and DynamoDB, which I've already said are special cases, your service is communicating instead with one of these other API services. So Secrets Manager is hopefully a very common one for keeping your secrets safe. There's also things like SQS, there's CloudWatch, there's any number of AWS services. Some are not covered by PrivateLink, but many of them are. And these types of services are endpoint services. And an endpoint service is essentially one where you know that you're hitting a specific address. In the S3 and DynamoDB sense, we're talking about network ranges. In the case of Secrets Manager, SQS, etc., we're talking about a specific endpoint address that we're going to reach in order to make our requests. So what we do is we set up an interface endpoint in our VPC. We say which availability zone subnet we want to assign that interface endpoint to, and under the hood, AWS is going to create you an ENI, an Elastic Network Interface, which looks very much like every other Elastic Network Interface you've used in your VPC, but you can't manipulate certain things about it. It's going to appear in your network, and it's tied to this PrivateLink service. So having created that interface endpoint, you now have an address, both DNS and IP, within the subnet that you've assigned it to. And when you send traffic to that interface, that traffic is then tunneled essentially over PrivateLink into the Amazon service that you're trying to reach. So now, instead of making requests of the API endpoint that is public for your Secret Manager secrets, those requests are going to be sent instead to your local interface using the DNS name that's created when you set up that interface endpoint. That traffic doesn't pass your internet gateway, and so it doesn't cost you transit bandwidth. It's secured because that traffic doesn't leave the AWS network. And you don't have to do anything special with firewall rules or NACLs or security group rules, because that interface that you're talking to get your secrets from is on your network. It's local, essentially. And this is the sort of the power of this thing, right? You can go and have a look on the AWS docs about which services you can hit this way. If you're accessing services from a private network and you would like to be able to not have any kind of outbound internet traffic traversing your VPCs, you can use PrivateLink this way to maintain all of your to continue to access all of your AWS services, but without having to go over the public internet for them. So this is really worth looking at. So the question I posed is, well, what if you could do that with your service? What if you could sell your SaaS solution to AWS using consumers in a way that looks like this sort of private model? Well, actually, yes, you can. And doing so is not that difficult. And it's not a very well-known thing that is possible. So not a lot of people are doing this. You should probably be looking at this if you're selling your SaaS service to an AWS consumer. Ooh. What? Sorry, my clicker has just taken me. I think my battery's gone in there. Let's turn that off before it screws me again. Okay, so private link. The pros of a private link relationship. You have a private network relationship, so you're not passing traffic over the public internet, and you therefore need no internet gateway. So you can actually guarantee and you can tell your compliance-oriented customers that their traffic is never leaving your network, and you can point to the architecture that makes that true. So there's no internet gateway. You're not passing traffic out to the outside world. Even if you add public IP addresses to instances, that isn't going to work. The traffic never leaves the AWS network. So anything going over private link is routed over AWS fiber, over AWS network infrastructure. And so you can guarantee that communication is never going out of your domain. It's unidirectional. So this is the big improvement over VPC peering. You present a service, and you offer it up for connection to your clients. They can send TCP traffic over IPv4 to that service, and you can't send anything back to them other than in the request, in the response to that request over TCP. So there's no sort of routing trouble because you can't see each other's IP address ranges. There's no possibility for your traffic to leak over that barrier. There's no risk of IP classes, as I mentioned, and this is cost effective. So there's although if you're not passing traffic over your internet gateway, you're not being billed for transit bandwidth. If you're passing traffic over private link, then there is a charge for that transfer over private link, and that charge is lower than the transit bandwidth leaving the internet gateway. And crucially, you as the service provider don't pay it. Whoever creates the interface endpoint in their VPC pays the charges of bandwidth for that service. So if you're currently looking at your costs and your cost per client, and you're seeing that the cost of running this service for your clients is pretty high, maybe you're transacting a lot of data, this could be a way of saving money as well as improving your security. So worth looking at from that perspective. On the downside, there's a bit of extra work required to do this in a multi-region fashion. I'm going to show you a diagram for that. And it only supports at present NLB, so Network Load Balancer, and API Gateway endpoints. So if your services are presented on something other than NLB or API Gateway, then there's going to be some work to do to make that work. For example, if you're using ALB, it's reasonably common practice to put an NLB in front of that ALB in order to present it by private link. That's nice and easy. So there are some limitations. The docs cover it in more detail. We can help you with working out exactly how you would do this. So for a single region client of your private link presented service, your diagram or your network is going to look a little like this. So over on the left, you've got the customer. On the right, you've got your network. There are VPCs in each. This is all in one region. You've created you're running your service in this case on EC2 instances, split across two private subnets. There's a network load balancer in front of that service, and that's how your customers are reaching the service and making use of it. Your network load balancer, then you in the console, you create an endpoint service, or in Terraform or CloudFormation, you create an endpoint service to associate with that load balancer. So once you've got an NLB created, there's another section of the load balancing part of the console to allow you to create an endpoint service. You then get a name for that service that you can share with your customers, and they can then use that to create their interface endpoints in their network. This is a little like VPC peering. There's a bidirectional acceptance required. You can't just arbitrarily connect to someone else's service. I mean, you can create services that allow that, but for the most part, if you're selling SaaS services to customers, you're probably going to want to allow some level of acceptance. On the customer side, they're going to create interface endpoints in their VPC, and they're going to give the name of the service that you've created. They're going to say which VPC and which subnets they're going to want that service created in. And then Amazon's going to take care of the rest. It's going to stand up this interface endpoints, ENIs. It's going to go to you as the provider for acceptance of that connection. You're going to accept it. This can be automated with SNS and Lambdas and so forth. If you like, it can also be limited by you can limit access by account number and various other principles. We're using IAM, so there's a bit of complexity there if you want to dig into it under the hood. But essentially what you end up with is the customer has this interface endpoint, which is one or more ENIs in their network, in their subnets, that when they send traffic to that ENI, that traffic is routed or tunneled, I guess, instead to your network load balancer in a secure and performant way in order to prevent your service. So exactly the same as I want to use Secrets Manager from my VPC model, but it's your service that's being presented instead. Hopefully you're all with me so far. The thing to bear in mind also here, you can serve multiple customers from one service presented via PrivateLink. So there's no need to set up NLBs or clusters for individual tenants unless that's a decision that you've made and that's what you want to do. But you can serve multiple clients this way within a single region. So I've said in a single region, if you want to do this across multiple regions, you want to present your service to clients in other regions and your service is running in a single region, then there's a little bit of extra work to do. In this, I've stripped out the multiple availability zones because this diagram was getting complicated. So assume when you see availability zone that there's actually more than one here. So here, we have the customer is creating their PrivateLink relationship in the usual way. I'm missing an arrow from this diagram, actually. Oh, no, that's right. So if you want to provide your service to customers in a different region, you need to create an inter-region VPC peering relationship between your VPCs across regions. You're going to create a network load balancer and thus a service endpoint in both of those regions, and both of those network load balancers are going to target servers or services in the cluster in the region where you're running the service. So you're presenting a network load balancer endpoint in every region that you want to provide service to your customers. That network load balancer is then routing traffic over to the one region in which your service runs. So there's a bit of additional latency to worry about. There's also data transfer costs between regions, but your customers' requests then, if you're running your service in region 2 and the customer's in region 1, then they make their request of the interface endpoint that exists in region 1. PrivateLink routes that request over to your network load balancer in region 1. Your network load balancer in region 1 is reaching your service providing EC2 instances or other infrastructure in region 2 and reaching that service over the inter-region VPC peering. Again, all this traffic is internal to AWS and therefore secured and not subject to internet weather, but you are there able to present your service to customers of multiple regions from a single region, if that's what you want to do. So a little bit fiddlier, but it is possible. There's also the question of, well, what happens if I'm selling to an on-premises consumer of this service? And this is where you might want to, if you're sort of, I guess if your system is one which is browser accessible to your end users, this is applicable here as well. That's less true in the VPC to VPC world, but let's say you're selling your service to a bank or a larger financial institution. They have a lot of stuff running on premises. They have their users on in their office networks. You can still do this over a direct connect relationship. So in this case, your customer within the region that is associated with the direct connect relationship that they have will create, as usual, an interface endpoint in their VPC, and their clients who are on premises will be able to reach the VPC over the Direct Connect relationship in order to hit the interface endpoint. PrivateLink then kicks in the usual way and passes that traffic over to your VPC and the network load balancer in order to hit the services that you're running. So all this is possible over Direct Connect for on-prem customers as well. If you're selling to on-prem customers who are not yet AWS users, this is a sort of good on-ramp for getting them there. And if they are working with other providers who can provide their services over PrivateLink, then there is good incentive for them to hook up the network to AWS with Direct Connect and do these things. That Direct Connect relationship, by the way, could also be a site-to-site VPN relationship as well, if they don't want to go the whole wired connection route. But the story here essentially is that because those services live within the because the services are presented within a VPC that they own, they can get at that from their Direct Connect relationship. So I've got a question that's popped up from Gordon, who asks, we have corporate customers around the world and we've been trialing Global Accelerator to try to improve throughput and latency in communication to our EU West hosted services, so far without positive results. Do you think this PrivateLink architecture could be as good or better for cross-region performance improvement compared with sending traffic across the intranet from the Far East to Ireland? So I don't actually know directly the answer to that. I'll be happy to talk to you about this afterwards, Gordon. My gut feel is that because Global Accelerator uses the same infrastructure, the same network infrastructure as VPC, cross-regional peering, and PrivateLink, that if you're not seeing the performance increases that you're expecting from Global Accelerator, you may not see improvements with the PrivateLink story either. That said, if you're having performance trouble with Global Accelerator, then that might be a conversation to have with your account manager. If you don't know who that is, please get in touch with me. I can set you up with an introduction to that individual, and we can work on that together. But that's a good question. I haven't personally had much exposure to Global Accelerator, but it does all use the same infrastructure as PrivateLink would. Bernard's asking, can PrivateLink be used to access private RDS from VPC A to VPC B? So yes, after a fashion. I believe that you can create a service endpoint for RDS and share it that way. I think the fact that you want or might want to do that might suggest an architectural problem. I don't think doing that is a good idea necessarily. But Bernard, obviously you have a support contract with the Scale Factory. Do open a question in our Slack channel, and we'll look at that for you. But yes, you can expose other services via PrivateLink, and actually I have a couple of slides on that as well. In fact, here we are, the other use cases for PrivateLink. This use case here is one that relates to that, I guess. You don't have to use PrivateLink only for sharing your services with your clients. You can also use PrivateLink to share your services with other VPCs of your own. And there are various reasons you might want to do that. Here's a really good use case that I picked up from there was a partner webinar about PrivateLink that covered this exact use case, and it sort of stuck with me because I know we have customers who do things a bit like this. So over on the right here, we've got a VPC that contains a shared service, and that shared service in this instance is a Squid proxy. Now we've got some customers who use Squid proxying on egress traffic in order to filter out, to check requests for viruses and to whitelist certain services outside their network, so they can see at layer 7 what traffic is leaving their network, where it's going, and do some kind of inspection on the results. So from a security perspective, this is kind of handy because it means that you can be completely sure about what's getting into your VPC. If your VPCs have no other routes into them from the outside world, then everything that comes into it must be via this sort of Squid proxy. And so they set up a Squid setup configured with proxy rules. there's a public subnet in front of that with a NAT gateway, and the traffic from Squid can exit the network out to the public internet over that public subnet. In this model, what we're doing is presenting actually, I shouldn't have drawn a join around that those two interface endpoints on the left. Ignore that. In here, we've got two separate VPCs, a production VPC and a staging VPC, for example. Those two VPCs don't have any external access to the internet. There's no public subnet. There's no network gateway. There's no internet gateway. And so there is currently no way for those networks to pass traffic to the outside world or make requests of external services. What we've done here is created an interface endpoint in each of those private subnets that maps to the network load balancer in their shared service account where their Squid proxy runs. And in the use case here, your containers would be, the software running in your containers would be proxy aware, or you'd maybe do some transparent proxy setup such that any requests to the outside world are then hitting the interface endpoint, are being tunneled to your Squid service using PrivateLink, and that egress traffic is then proxied out using Squid and filtered in the usual ways. So you can be sure that your production and staging VPCs are not passing traffic to the outside world except via the Squid. And that Squid is a centrally managed single service that you can then watch for all of your environments centrally. Also means that you're not then setting up separate Squids, separate NAT gateways, etc. in every subnet or every VPC that you're running. And as a result, you're probably going to reduce your costs as well as increasing your visibility of what's going on. Things to bear in mind about this whole setup. Interface endpoints can only be set up in one subnet per availability zone. So most of you won't worry about this as a limitation, but it is a limitation of PrivateLink, that if you're creating interface endpoints, they can only be assigned to a single subnet within an availability zone. That's a limitation. It's only TCP. So you can only make stateful requests over PrivateLink. It's also currently only IPv4. IPv6 support is gradually coming out across various AWS services, so no doubt that will change in time, but it is currently an IPv4 only service. But it's all internal, so that's probably not going to be a big problem for you. If you want to see the source IP address of the originator of the requests of PrivateLink, you need to be using the proxy protocol in your applications. So the requester address is part of that proxied traffic, and comes through, hits your network load balancer and is in the headers of the request that it makes of your backend services. So you can get at that data, but you have to work to do so if you care about that sort of thing. The network performance of this is designed for 10 gigabits per second per availability zone, but it will burst to 40 gigabits. So sustain 10, burst to 40. Bear that in mind when you're sizing these things. There are ways of increasing the throughput of that by kind of running multiple of these in parallel. You don't want to do that if you can avoid it. You've got to bear in mind availability zone identifier matching. So if you're running your service in 3 availability zones in Ireland, for example, and your customer is also consuming your service from 3 availability zones in Ireland, there is no guarantee that their EU West 1A is the same physical availability zone as your EU West 1A. This is a sort of little known fact about availability zones. They're allocated on a per customer basis. You can find out the availability zone identifier that underlies that from some of the metadata and some API calls. But bear in mind that if you're reporting a problem in an availability zone, that won't necessarily match the availability zones that your customers are using it within the same region. So that's worth bearing in mind. And from a cost perspective, the customer, so the people setting up the endpoints interface, so the interface endpoints in their VPCs, are paying an hourly rate per endpoint per VPC. So there's a cost to having an interface endpoint standing. It's like a cent an hour or something. It's pretty small, and they will pay per gigabyte of data processed by the PrivateLink connection in either direction. So that it doesn't matter about the direction in this particular case. So as a service vendor, the fact that you can hand off a lot of your costs to the customer, probably quite positive, but you need to set the expectations that that's what's going on. So that's the technical stuff. I hope that's been a useful kind of tour of the stuff. I learned quite a lot while I was doing this. This was not material that was necessarily familiar to me, and I hope I've explained it well to you. If you'd like to talk more detail about this after we're done, I'm more than happy to set up a call with you and sort of talk about how this might work in your use case. I'm going to hand over now to Dara from AWS, who's going to talk a little bit about you as an AWS technology partner, and the sorts of things that AWS can do to help you and your business, and also talk about how the PrivateLink Service Ready program can also benefit you in that world. So Dara, over to you.
Thank you, John. Okay, let me share my desktop. Can you see? Is it good?
Where's my screen? I can't see my screen. Everything's hidden under stuff at the moment.
Yeah, that's the way it works, right? I hope so.
Yeah, I actually can't. Zoom has entirely disappeared from my screen right now, other than the windows with chat and attendee details in. So let's assume that yes, your screen can be seen, and someone can type in the chat if not.
Okay, that's great. Okay, so we'll just start a little bit with defining a little bit about the APN partner network, or the AWS partner network. And this is a global partner program that helps AWS partners build successful.
So right. Okay, we can't see your screen. Great. Okay, let's try that again.
Okay. So what's happened to the Zoom? Let's expand the Zoom. We'll share the screen again. Desktop 2. And then, can you see now? It seems to say that it's doing it, right?
I still can't see my Zoom window anywhere.
Okay.
Now I can see it.
It's
okay,
gone.
great.
Okay.
No, okay, we're good.
Awesome.
This is going to be really difficult when I come to share my screen again later, because I don't know where the buttons are. But
yeah,
but do go on.
Yeah, this is a problem when you've got too many screens. Okay, so yeah, as I was saying, the APN partner community. I mean, this consists of thousands of partners globally. We divide these into consulting and technology partners, and I mean, 90% of the Fortune 100 companies are AWS partners and part of this community, either as consulting partners or technology partners. The technology partners, which I guess will be more interested here, we don't categorize them specifically, but they're usually software, delivering software as a service. They may be delivering software in the marketplace, or operating systems, databases, either managed or self-hosted, or hardware devices. When you join the APN, let me just move on here. We have a tiering program. There are 4 tiers for consulting partners, including Premier, but for technology partners, we have 3 tiers. And these are, you start with a registered tier, and then move to the select tier, and then onto the advanced tier. And this represents your journey on maturity on their AWS. And as your business grows, then you would move from one tier to the other, and this provides and unlocks access to different programs and benefits. Upon joining, there are quite a lot of benefits, and I'm not going to go into the details of each one here, but the most important part is that you would get in contact with a partner development representative immediately, which helps you to navigate through the various paths, benefits, fundings, go-to-market programs, business plans, and how to actually navigate all of the different systems that are available. And I work with this PDR team. So as a partner solution architect, and part of my role is to evaluate the solutions that the technology partners are delivering, and to help them move through those tiers. And we'll see a little bit later on how that gating is kind of done. The general motion that's involved here is this kind of virtual cycle where customer success and customer references are fed into marketing and lead generation. And then that helps with our sales teams who can help partners to grow their revenue and, of course, move through from registered to select and to advanced tiers. We also provide product optimization recommendations. And as the partner develops, it becomes clear through their specialization which programs make more sense for them. For example, they may want to be database ready. They may be maybe a startup that we would consider as part of the global startup program, or maybe they're a software as a service and it makes sense for them to take advantage of the business and technical enablement content paths that we have through the SaaS factory. As the partner gets to the advanced stage, they may apply for competencies, and those competencies may be in financial services or many different verticals, or they may be competency in a particular workload type like Microsoft or SAP. But it all depends on what the partner is specialized in. One of the major programs that we have that partners are interested in is the customer engagements program, which provides tools and resources and that helps to support partners in their sales engagements. And this program is all about opportunity sharing, and the tools are provided for partners to manage pipelines of opportunities. So opportunities that are provided to AWS in order that we maybe become available to other partners that this partner doesn't specialize in, but also opportunities provided to partners based on requests by customers. This is one of the major programs throughout AWS and is usually one of the first go-to places when a partner moves from the registered tier into the select tier. Of interest here, especially because we're talking about a particular AWS service that is PrivateLink, are the service ready program designations. And by specializing or having a solution that involves any of these areas like Lambda, Linux, Redshift, or RDS, or PrivateLink, AWS can recommend these partner solutions to customers based on an evaluation by the solution architect. I guess what the idea here is that we hone in a little bit or focus on, as we begin to focus on PrivateLink, this enables partners to make available their solutions to other AWS customers through the PrivateLink visibility programs. And one of those visibility programs is the PrivateLink Marketplace. So the PrivateLink Marketplace allows technology partners that have developed solutions that are made available through PrivateLink to make those available and discoverable on the marketplace to AWS customers, and not only through direct recommendations through solution architects or through AWS sales staff. If we go through, I mean, John has already gone through many of the benefits of PrivateLink, but it might be worth running through some of the things that are of interest again. And one of the big ones is, of course, the ability to leverage the compliance standards that are implemented across the AWS network, the PCI, HIPAA, PSD2 in the UK. And this is particularly important for companies like financial services and healthcare. And we are seeing customers and partners who have developed software as a service, particularly in financial services or healthcare, now begin to look more seriously at PrivateLink and to be able and to offer PrivateLink as a connectivity option to their customers as an alternative to their current either VPN or transit gateway type connectivity. This is happening more and more, and I think it's going to happen more and more into the future. It's one of the, John mentioned already, the the data egress costs. And it's important to remember that this is a big deal for customers, because partners who are using AWS PrivateLink can go to customers that they currently already have, who have got a high spend potentially on the data egress costs, and make them aware that PrivateLink can introduce 50 to 90% cost savings on what might be on the traffic that currently has to exit the AWS network. Because the new customer onboarding is a lot more simple when it comes to PrivateLink, customers don't necessarily have to set up complex VPC peering, set up all those security groups, set up all the NACLs that John mentioned earlier, and the complexity that's involved in that kind of a networking. This can dramatically decrease the amount of time it takes to onboard new customers when it comes to taking advantage of PrivateLink. The network connectivity, of course, the decreased latency, high performance, and 10 gigabytes per second is not necessarily something that all customers are aware of, but it's very important that it is seen as a benefit, because it may not, the first time customers are using software as a service, it may not be apparent to them what the growth is going to be. So I guess if we boil down the benefits, they can be boiled down to three simple things. So it allows customers to secure their traffic and keep them away from the weather, if you like, and the security threats that happen across the internet. The strict client to server access can authorize traffic using security groups. So it is possible for customers and for service providers to lock down the traffic using security groups. The simplified architecture would minimize the operational overhead and avoids the hassle of managing multiple infrastructure components. You can whitelist IPs, and this is not something that's immediately obviously able to do if you have to go over the public internet. The scalability, of course, you can PrivateLink can scale to provide service to thousands of customers and support overlapping IPs, which is an important benefit that John mentioned earlier. Yeah, if your customer already has got their VPC, which uses an IP range that in any way overlaps with a VPC, then a VPC peering is not necessarily going to be the solution for you. And reorganizing a VPC IP range is no easy task if you've got a lot of devices running in there. So we mentioned already the servers ready programs, and the benefits of the servers ready programs come in three different types. We mentioned the marketplace. We do have an AWS PrivateLink web page for partners with solution on there. Partners can get promoted on the AWS Partner Network blog, promoted through sales teams and AWS PrivateLink teams. Right now, we have a program going on, and Nicholas is part of that program, which is to promote PrivateLink-based services to AWS customers. You can surface higher in the Partner Solution Finder with results related to AWS PrivateLink search. You can meet ACE program participation requirements by introducing customer references and customer case studies based on PrivateLink. And because PrivateLink is a new and potentially not so well-known offering by AWS, there are new case studies opportunities which would increase a partner's ability to meet the ACE requirements. One of the things that is required, I guess, to become a PrivateLink ready partner is the technical baseline review, which is a review available to all partners for their solution on AWS. And this evaluates the solution for uptime, operational excellence, security, backup and recovery. And the idea here is that ultimately customers can benefit from an all-round more resilient solution, but it also provides a check mark and a validation to allow our sales team to recommend that solution to our customers. So qualified partners are guaranteed that they're following proper rules for IAM, they're using connection pooling, that they've got the correct auditing in place and security. And the idea is that customers, of course, receive the proper documentation on how to correctly configure and deliver their solutions, connect their solutions to AWS PrivateLink. So when it comes to technology partners, I mean, if you're already in the haven't already applied to the APN, I recommend you contact me or contact Nicholas, and we can get you started straight away. Are you there, John?
Yep. Is that you done?
That's me done.
Great stuff. Thank you. I'm going to stop your screen share and share my own screen again, just to wrap up. So that button, and then again that button. I found my window; it was hiding over on a different virtual desktop, which is quite annoying. Thanks, Darren. So your next steps from here. I've got a couple of other webinars I've run recently on SaaS journey in general on AWS. So if you are currently building your SaaS platform and you're an AWS user, and you'd like to sort of get some more perspective on how you might think about your design in terms of tenancy and security and so forth, then that's worth looking at. I also have a webinar on architecture for security, which covers over about 90 minutes. We look at all the security services provided by the platform, or nearly all of them. Those two webinars I've given recently, I'll probably give them again in the near future. You can find those on the website if you're interested in that content. There's video there, and if you're pushed for time, you can watch me in 2x speed and watch me talk through them like a chipmunk. If you are a CTO or a technical decision maker in your organization, and you would like the opportunity to network and discuss particularly ops topics with other CTOs, I run an event every 4 weeks called Breakfast Ops, which is a discussion forum. We used to do this in the office and provide bacon rolls and such. Obviously, we can't do that anymore. We do that now on Zoom. So if you are a CTO, please get in touch and I'll get you onto the mailing list for that. You may also be interested in a well-architected review with my team. I mentioned this sort of earlier on. We've run over 200, probably over 220 of these in the last couple of years. It's a really great way to get an assessment of your practice on AWS as it relates to operations, security, performance, reliability, and cost. There's also some funding available from AWS to resolve any issues we find during that type of review. So do get in touch if that's interesting. Now, I asked Dara to hang on the line because there's some. He mentioned a technical baseline review. Well architected is another type of review. I guess, Dara, what are the differences between the two, and how can we help teams with what we're doing meet the requirements of a technical baseline review?
Well, the difference between the two is that I guess one might be considered a type of audit, and the other is more kind of a conversation and a steering review. With the well-architected, you can decide to pick and choose, I suppose, what makes most sense for you. You may not necessarily want to optimize for cost. You may be more interested in operations than performance, and you may be less interested in security than you are in reliability, for example. And the customer can choose which areas to focus on, take those questions and those best practices, and then actually decide what makes most sense for them to implement or to remediate over the coming months in accordance with the technical strategy. And in that sense, the well-architected review is a very good kind of incremental way to improve, the overall quality of a solution. The technical baseline review is really a little bit more of an AWS type audit according to very specific best practices that would probably apply to almost every solution. certainly, and we have particular technical baseline reviews for software as a service, or for customer deployed, or for direct connect type solutions. So there are specific best practices that we would expect to see in there, and they broke down in several areas, like how you control access to your AWS environment, how do you handle encryption, do you have an RPO and RTO defined, how you do backups and security, how you do backup and recovery, do you do a DR test, how often do you test your backups, and all of those, and those kind of things. They're the kind of things handled in the technical baseline review. And what we've discovered is that because there are a lot of well-architected reviews going on and a lot of technical baseline reviews going on, there is some overlap, of course, in some of those areas, and it can make sense to do to roll the two together. And of course, if a partner passes a technical baseline review, it contributes, of course, to whether or not they can move through those tiers that I mentioned earlier on, say from select to advanced, or they can qualify for something like the PrivateLink service ready program that we mentioned.
Gotcha. Cool. So I guess well architected is a bit of a sort of opt-in. You can choose to make those improvements if they make sense for you, but the technical baseline review, you have to pass that in order to move through the tiers of the partner network. But there's a bit of overlap in the things they cover.
Right, and because there's a bit of overlap there, if you're evaluating, for example, the security in a well-architected review, it could make sense to incorporate the best practices that are expected in the technical baseline review, instead of having to go and do it again later, having to repeat the process. Yeah.
Yep, that makes sense. Cool.
Yeah.
Thanks, Dara. I'm just popping you on mute now. So do book a well-architected review if you haven't had one. It's a really great opportunity to learn some more stuff about how you could be operating your platform. And as I said, there's funding available to support improvements from the back of that as well. Other things that we're doing at the Scale Factory, we have a support and learning subscription model, which provides developer support to your team. So we're available via Slack for your team to pitch in with questions about what they're doing on AWS. We can answer questions about PrivateLink setup. We can answer questions about how to do this thing with CloudFormation, or why is this particular IAM policy not working, like those sorts of things. So we're sort of an augmentation of your team, I guess, through the working day, particularly where it relates to infrastructure and operations. We also run surgery hours as part of that, so you can dial into a Zoom call with one of my team to work through something a bit trickier with a screen share, and out of hours, in fact 24/7, you can call us at any time to help you resolve a service affecting incident. So this is sort of augments AWS's support services. So if you're already maybe paying for business support on AWS, then obviously that's a sensible thing to be doing for your production environments. You could also be engaging with us to help you build the things to go into those environments. We also run monthly training sessions on particular AWS topics. So we do some stuff on foundations, like getting your team up to speed with IAM appropriately. We also run occasional courses on sort of quick intros to specific topics. So we've done a course on Terraform, for example. We've done one on Fargate. It's a good way of getting your team to learn some new stuff that might be relevant to the job that they're doing. So do get in touch if that is of interest. I'll be happy to stick around and field some more questions if you have any. If not, then thanks for joining. I will be in touch with a link to the video and the slides, and some more information about the APM program that Dara was talking about earlier as well, and details about our upcoming program of webinars and breakfast ops. So thanks for your time and your attention, and hopefully we'll see you again soon.